When people think about the parts of a septic system, big components like a tank or drain field pipes usually come to mind. But the soil that wastewater ends up in is actually the most important part of the treatment process. Without proper soil for treatment, germs and minerals can get into groundwater and can impact the health of people, animals, and the environment. When a septic system is installed, it's important to ensure the soil type and depth are considered. This video is intended to teach you the basics of how to analyze soil texture and structure to determine what kind of system is needed. Please note, this video is being produced to address the soils and regulations in the state of Washington, specifically for what are called small on-site septic systems that have a flow of less than 3,500 gallons per day. In this video, we will discuss the role of soil in treating wastewater, show you how to determine the texture, composition, and structure of soil, and help you determine where a water table or restrictive layer is. If you only need to brush up on certain skills, you can refer to the description of this video to click the timestamp for the section you want. First, let's talk about what wastewater is and why it is important it gets treated, in this case by septic systems. Wastewater includes any water used in a building, including from sinks, dishwashers, baths, laundry, or toilets, as well as anything that is in that water, such as soap, food, chemicals, and human waste. Wastewater can carry germs that can be harmful to humans and wildlife, including viruses, bacteria, and other microorganisms. These are called pathogens. It also contains nutrients like nitrogen and phosphorus that can have a negative effect on ecosystems. As wastewater trickles down through soil, it can remove or neutralize these things. When we talk about soil, what exactly do we mean? Soil is comprised of minerals, organic matter, liquids, and gases. It has distinct layers and the ability to support rooted plants. When we stand on the ground, it's firm underneath our feet, and it's easy to think of it as completely solid. But really only about half of the soil is minerals and organic matter. The other half is space between the soil particles, which is filled by air or water. As wastewater trickles down or percolates through these spaces in the soil, pathogens are removed or neutralized by the soil, treating the water before it gets into groundwater. Soils with different texture and structure will let water percolate at different rates, which means varying amounts of time for treatment to happen. For this reason, there are strict rules about the depth of soil needed depending on what type of soils are present. Washington State's on-site septic regulations have 7 soil types that determine what kind of septic system can be installed. Soil types are described by their structure, texture, and how much is considered gravel or rock. So on-site septic professionals must learn how to determine each of these to do a proper site analysis. To do so, you have to dig a hole and get your hands dirty. But this video will be a good place to start, or to get a refresher on the most recent best practices. Check the description below this video for a full list of everything you'll need in your toolkit. To analyze the soil where a septic system will be installed, you need what's called a test pit, which is usually dug with an excavator by a professional. Before you enter a test pit, make sure it is safe to do so. Excess dirt must be at least 2 feet from the edge, and all nearby machinery should be turned off. There should be a ramp of no steeper than a 34-degree angle to walk down, and you should never enter deeper than 4 feet. If there are cracks in the pit wall or the soil is not stable, do not enter. An excavator might create a smooth, compacted surface on the side of the test pit. Because of this, you'll first want to use a rock hammer, spade, or whatever else you have on hand to dig into the test pit wall and break it up a bit. This will reveal the natural structures of the soil. Next, it is very helpful to hang a tape measure from the top of the test pit so you can easily reference the depth. You'll be writing down the beginning and ending depth of each layer on your record sheet, which is often called a soil log. Any leaves, sticks, or other organic debris do not count as soil, so start your measurement below that. Now, take a step back and notice the different bands or layers, sometimes called horizons, that make up the soil profile. There are usually clear changes in color or pattern that show where the soil changes composition. Use golf tees, nails, or whatever you prefer to mark the start of each new layer. It is important to analyze each layer separately, since they will likely be different types of soil. If it's hard to tell if there's a change, it's best to be safe and mark it as a new layer, since it will never hurt to analyze the same soil twice and have more information, but if you miss a layer, it might cause problems. Before you begin, look for signs that the soil may not be naturally formed. Garbage or construction debris, a very abrupt change in color, or a buried layer that looks like topsoil are all signs of what is often called fill soil. If the soil is not original or has been disturbed by human activity, it cannot be used for septic treatment. If it is original, now you're ready to analyze each layer. The first attribute we'll look at to determine soil type is the structure. Structure is the way soil particles are arranged into groups or shapes by naturally occurring processes over long periods of time. Figuring out the structure of soil is very important because it's a great way to gauge the porosity of the soil. Porosity means how much space there is between the particles of soil. Soil types that are more porous will allow water to trickle through much faster than soil types that are not very porous. To determine the structure of a soil, take your digging tool and knock some chunks of soil into your hand. Look at the natural clumps or units of soil, called PEDs, and match the shape with one of the pictures from the NRCS Fieldbook. The most common soil structure for the top layer of soil is called granular. Granular structure is characterized by small, round pellets. Sometimes these small PEDs will clump together around roots that are often found near the surface. Another very common soil structure is blocky. Blocky soil has distinct blocks of soil that have about the same length, width, and depth. Blocky is further categorized as either subangular or angular. You can think of subangular blocky PEDs as having more rounded edges, while angular blocky PEDs have pointy edges. Less common soil structures are columnar and prismatic, which are identified by columns that have a similar length and width but a much taller depth. Similar to blocky structure, columnar soil PEDs are rounded at the end, while prismatic structures have sharper angles. Platy structure is made of shapes that are wide and thin. It looks a lot like little layers stacked on top of each other. Occasionally, you may come across soil that is considered structureless. These include single grain or massive structured soils that are loose particles with no discernible PEDs. Look at the side of the test pit wall and the PEDs in your hand to determine what structure matches most closely. Once you have determined your soil structure, you will need to figure out the strength of the structure, which can be weak, moderate, or strong. Weak structure means you can barely tell what the structure is when you observe it in the test pit wall or in your hand. Moderate structure is when the units are easy to identify in either the soil profile or in your hand, but not both. In this picture, it is not obvious what the structure is in the wall, but when some PEDs are knocked out of the wall into the hand, it's very clearly angular blocky. Because it is clear in one place and not the other, this would be called moderate angular blocky structure. If it was obvious in the side of the test pit, but then it was hard to identify in your hand, it would also be moderate because it is clear in one place and not the other. Strong structure is when the structure is clear in the side of the test pit and remains clear when the PEDs are knocked out into your hand. The strength of the structure has nothing to do with how easy it is to break up the PEDs. Don't try to pinch or smash them, just follow the rules that we reviewed. See if you can tell what the structure of this example is. What shape can you see? This looks like granular structure. Can you see the shape of the soil units clearly in the soil wall? Yes, it's easy to see the shape of the PEDs in the soil. Can you see the shape of the PEDs clearly in your hand? Yes, the shape of the PEDs are obvious in your hand. You would call this strong granular soil structure. Write down the strength and structure for every layer in your soil log. Texture is another characteristic of soil that is used to determine what kind of septic system can be installed in it. Like structure, texture also indicates how fast water will percolate through it. You may think of clay as a material to make pottery, or sand as something that you find at the beach. But in soil science, clay, silt, and sand are terms that describe the specific size of the soil particles. The texture of a soil indicates the amount of clay, silt, and sand that make up the soil. According to USDA soil standards, there are 5 different grades of sand, with particles ranging from 0.05 millimeters to 2 millimeters in diameter. They are classed as very coarse, the largest, coarse, medium, fine, and very fine, which is the smallest. If you have a sandy soil texture, you will need to use sieves to determine the grade of the sand. We will discuss how to use sieves later in this video. Silt particles are between 0.002 and 0.05 millimeters, and any particles smaller than 0.002 millimeters are considered clay. Different combinations of grain sizes have different names. The textural triangle is a tool used to determine a texture class based on the percentages of sand, silt, and clay. To use it, start with a percentage of clay and follow the horizontal line from the left side of the triangle to the right. Then, find the percentage of silt and follow the diagonal line down until it meets the horizontal line. Or, you can use the percentage of sand and follow it up until it meets the horizontal clay line. So if we had a soil with 30% clay, 30% silt, and 40% sand, we would start at 30 on the clay line and follow it until we hit the diagonal line coming down from 30 on the silt line. This would be a clay loam. You can determine soil texture by sending it to a lab for an exact analysis. Fortunately, there is a much quicker and less expensive way to effectively determine the approximate makeup by manipulating and feeling the soil with your hands. There are several steps involved, but it's a straightforward process. Let's walk through it now. If you haven't done it before, we recommend you watch the whole process from start to finish, and then, if you can get some soil, watch the process again and pause the video after each step to try it. First, get a handful of soil out of the wall of the test pit for the layer you're analyzing. Use a squirt bottle to get it wet. Knead and work the soil in your hand. It should be wet enough to feel like Play-Doh or silly putty. If it is too dry, it may crack and crumble when you are working with it in your hand. If it does, add more water and try again. If it gets too wet and becomes muddy and falls apart, then add more soil from the same place in the test pit wall and work it in with the rest. Or you may discard the mud and start over again. Once you have a ball about the size of a ping pong ball or golf ball that is the right consistency, continue smushing, folding, and working the soil for a few minutes to break up any clumps the soil may have. This will ensure the following steps will not be affected by the existing structure of the soil. Now we are going to test this soil to see if it is considered sand. Again, it doesn't matter if you are anywhere near a beach. Sand is the technical term for soil with certain sized particles. Take your soil ball and put it between your palms. Apply a little pressure and roll the ball around between your hands 5 times. If the soil is almost entirely sand, the ball will fall apart, and you must use sieves to find the grade of the sand. If your soil ball passes the sand test and keeps its shape, the next step is to try to make a ribbon out of it. This will take some practice. To make a ribbon, put the ball of soil in your hand so that the end is between your thumb and your forefinger, which should be perpendicular to each other. Use your thumb to push the soil over your forefinger so that it makes a band a few millimeters thick that sticks out from the ball. Hold your other hand underneath to catch the soil if it falls off. If the soil always falls off without sticking and forming more than the smallest ribbon of soil, this is a loamy sand. Again, you must use sieves to determine the grade. If, however, the soil does form a ribbon, keep pushing more of the soil past your pointer finger to make the ribbon longer and longer. Eventually, the ribbon will break off into your other hand. Do this step 2 or 3 times until you have a few ribbons and check to see if they are a consistent length. The length of the ribbon is important for the next step in the texturing process, so if you have drastically different ribbon sizes, you may want to squish it all back into a ball and start the ribbon process over. Making a ribbon out of your soil ball often takes lots of practice, so don't be discouraged if you don't get it right away. To help you gauge if you are ribboning correctly, it may be helpful to practice with soils you already know the texture of, or consult someone with experience doing hand texturing. Once you have a few ribbons from your soil ball that have fallen off, measure their length. Always use a ruler or tape measure since it is easy to misjudge the length if you are eyeballing it, which can lead you to come up with the wrong soil type in your report. If you have ribbons that are 2 inches long or less, then the soil contains up to 25% clay. If you have ribbons that are between 2 and 3.5 inches, then the soil is about 25% to 40% clay. And if you have ribbons that are greater than 3.5 inches, then the soil is greater than 40% clay. So the longer the ribbon, the higher the clay content. Write down the length of the ribbon or keep it in mind while we do the final step of the process. Note that these ribbon lengths are specific to Washington soils. There is one more step you need to do to determine a soil's texture. Take a pinch of the soil that you made ribbons out of and put it in the palm of your hand. With your squirt bottle, get this soil very wet so that it is muddy but not quite washing off your hand. Now, take a finger from your other hand and rub the soil around in your palm. Ask yourself, does the soil feel very gritty under your finger? Can you feel a lot of individual grains that are large enough to notice? If so, then there is a significant amount of sand in your soil. Ask yourself, does the soil feel very smooth in your hand? Does it feel like you are rubbing jelly or thick dish soap in your hand? If so, then there is a significant amount of silt in your soil. You may feel some grit in a smooth soil, and you may feel some smoothness in a gritty soil, but think about if it is predominantly one or the other. In some cases, neither feeling is dominant, or you can't tell, and this is a third category. Now we are going to put the ribbon length and the feeling together to figure out what the name of the soil texture is. Match up the ribbon length at the top of this chart with the feeling you had on the side of the chart and see what texture has these characteristics. For example, if you had a ribbon length of 3 inches, which would be the middle column, and the soil felt very gritty, which is the top row, then this soil would be called a sandy clay loam. If you had 1-inch long ribbons and the soil felt mostly smooth, what type would it be? This would be the first column, since it's less than 2 inches, and the second row for smooth, which would mean this soil would be a silt loam. There's a link in the description of this video to a flowchart that you can use to follow these steps to find the texture of your soil. If you've determined the structure and texture of a soil, there is one more characteristic that you may need to determine to figure out what soil type it is: the amount of rock fragments. Any mineral pieces larger than 2 millimeters in diameter are considered rock fragments, or gravel. To figure out the volume of rocks or what grade of sand is in a soil, you'll need to use sieves. Sieves are metal filters, like a colander you might use in the kitchen, but they are specially made with holes that are very precise in order to filter certain soil textures. Sieves are labeled with a number that indicates the number of holes per centimeter. This relates to the size of soil particles it lets through. For example, a sieve with 2 millimeter holes is called a number 10. A number 18 sieve has 1 millimeter holes and will filter out coarse sand or anything larger. To filter for different kinds of sand and rock, you'll need a set of sieves that can stack on top of each other. Let's look at how to grade sand. In Washington, you'll need the following numbered sieves: 10 for rocks, 18 for very coarse sand, 35 for coarse, 60 for medium, 140 for fine, and 300 for very fine sand. Make sure to put the finest mesh with the largest sieve number on the bottom of the stack and the pan underneath it to catch everything else. Stack the sieves in descending order until you have the one with the lowest number on top. If you can, use a clear container with markings for different volumes, such as a paint bucket or a measuring cup, to put a known quantity of soil into the top of the sieves. The soil should be very dry so that the smaller particles don't stick together and fail to make it through smaller holes. Put the lid on top of the stack and shake the whole stack until the different particle sizes have been thoroughly separated. Particles will filter down through the different sieves until they reach a mesh that they are too big to go through. Once you're done, take the sieves apart and compare how much of each grade is in the sample. You can put the sand back in your measuring container to get precise percentages. If the result is uncertain and it may affect the soil type, then you can send a sample to an agricultural laboratory who can test for a precise texture. Check with the lab about what volume they need before sending them your sample. To find out the percentage of rock, you will only need your number 10 sieve and the pan to catch the soil. Everything but rock fragments will fit through the number 10 sieve. For this analysis, you will need to know exactly how much soil you are filtering, ideally something easy to divide, such as a liter. If possible, a clear plastic container with measurements will give you the most precise reading. Shake the sieve until you have filtered the entire quantity of soil through it. Then, put all of the soil left after removing the rocks back into the original container. Measure the volume of the soil and subtract it from the original total volume before the rocks were removed. The result is the volume of the rocks. Never pour the rocks in by themselves to measure their volume because the spaces between them will be measured as well, making it seem like they have a larger percentage. Divide the volume of the rocks by the original volume, and you will have the percentage of rocks in the soil sample. For example, let's say we take 1 liter of soil and we put it through our number 10 sieve. When we put the clay, silt, and sand back into the bucket, we can see that the bucket is full up to 0.8 liters. If we subtract 0.8 from 1 liter, we know that there were 0.2 liters of rocks in the sample. 0.2 divided by 1 gives us 2/10 or 1/5, which is 20%. So we know this soil is 20% rock fragments. Different percentages of rock have different labels. If 15 to 35% of the volume is gravel, then it is considered gravelly. If 35 to 60% of it is gravel, it is considered very gravelly, and above 60% is considered extremely gravelly. Any soil with more than 90% rock fragments is considered type 1 regardless of the texture. Once you know the structure, texture, and percent rock of the layer of soil you are assessing, you will have the information you need to determine the soil type. There is one more piece of information you should be writing down for each layer of soil that you analyze, and that is the color. This doesn't just mean writing down brown or gray. The field of soil science uses the Munsell color system, which categorizes a color by hue, chroma, and value, in order to give a very specific data point about the soil. Hue is the basic color, chroma describes the intensity of the color, and value indicates how light or dark it is. The color can give important information about drainage characteristics to someone who may read your report at a later date. The process of identifying a soil's color using a Munsell color book is straightforward. There is a page for each hue, with blocks of color for different combinations of chroma and value. The hue is written on the top of the page, in this case 10YR, which represents a shade between yellow and red. Along the left side of the page is the value, and the chroma is along the bottom. If you can't get an entire Munsell book, you should at least bring individual pages with you when you analyze soil. 10YR and 7.5YR will be most useful for soils you will find in Washington State. Take a handful of the soil you're looking at, wet it a little, and hold it up behind the page. Move the soil behind the circles cut in the page and compare it to the printed color blocks until you find the closest match. If none of them match well, try different pages until you find one that does. Once you've identified the color block that fits best, write it down using this format: the hue of the page, then the number for the value, a slash, and then the number for the chroma. In this case, we've decided that this block is the best match for our soil. So you would write down 10YR 3/4. Make sure you are not wearing sunglasses when you classify a soil's color. And Munsell color books are printed with great precision, so you should never use a picture on a mobile device or printed from a computer. Washington State on-site septic codes state that there must be a suitable amount of soil for treatment before you reach the depth of either the highest seasonal water table or a restrictive layer that isn't porous enough for the wastewater to get through. Let's take a look at each of these situations, starting with how to tell where a water table is. There are two ways to tell if you've reached the water table, or the depth of groundwater for your site. In some cases, it may be obvious when you dig a test pit or a monitoring well and you can see the water in the hole. Make sure the standing water isn't because of something temporary, like recent rainfall or irrigation, that hasn't had time to drain yet. In other cases, there may be evidence of where the water has been consistently present, even if it is not there at the time when you are doing your analysis. When soil is saturated, meaning the spaces between the soil particles are almost completely filled with water for an extended time, natural processes of the bacteria in the soil will cause discolorations. These variations in color are called redoxomorphic features and are commonly referred to as mottling. Mottled soil has three distinct colors. The matrix color is the dominant color of the soil. You can think of this as the normal color that the soil would have without mottling. When soil particles are oxidized, meaning they are losing electrons as part of these chemical reactions, the color becomes brighter. Another process is called reduction, which refers to reducing the amount of oxidation. In other words, the soil is gaining electrons. When reduction happens, there will be a loss of color, and the soil will look less bright. If you look at a Munsell color page, the oxidation color will appear higher in chroma, and the reduction color will appear lower in chroma. When you find mottling, you should document it in your soil log. Be sure to include the Munsell color code of all three of these colors. There are exceptions, but generally, mottling has all three: a matrix color, oxidation color, and reduction color. When you find significant amounts of mottling in a layer of soil, you have found the water table. This soil cannot be used for treatment. In addition to a water table, if you reach a depth with a restrictive layer, then the soil is no longer suitable for treatment. A restrictive layer is a layer that is too hard for water, roots, or air to get into. This could be a solid layer of rock, like bedrock, or it could be a hard pan, which is a layer that has been so compacted that it's almost as hard as solid rock. Additionally, any soil that you determine to be type 7 is also not usable for treatment. Now you know all the steps to analyze soil that may be used for a septic system. After the site and soil evaluation, the septic designer can get to work designing a system best suited for that site. Here's a recap of the steps in the process. Prepare the test pit wall. Mark the different layers and make sure you know their depth. For each layer, figure out the structure. Follow the flowchart to find the texture. If the soil is sandy, use your sieves. And if there's significant rocks, find out what percentage. Always note the color, and look out for water, mottling, or a restrictive layer. And write down all this information in your soil log. While this video has given you a guide on how to assess soil, we strongly recommend you attend a soil class in person to get hands-on experience and learn from an experienced soil scientist. These skills are not complicated, but they take time to practice and master. So take every chance you have to practice and check your work against soil with known qualities to improve your accuracy. Remember, soil is a crucial part of the treatment process of a septic system. Thank you for being interested in learning or perfecting this craft to better protect the health of nature and your community. For more information, check the description of this video for links to other resources.